Hi guys! In this video we're going to work on simplifying rational expressions. Rational expressions are basically just fractions that look really complicated. They have a numerator and a denominator that usually have a bunch of x's in them. A lot of times you can factor the numerator or the denominator, or both maybe. So we're going to work on simplifying a few types of these. The first problem I have written down is subtracting, and adding would work very much the same way. Step one is to factor the denominators if they are factorable. This first one is, it would become 3a plus 2b times 3a minus 2b. Now, the other denominator doesn't factor at all. It's just already 3a plus 2b. So to be able to subtract, we need common denominators, which means this second denominator needs to be multiplied by 3a minus 2b. And if we do it on the bottom of that fraction, we also have to do it on the top, like that. Okay, so now I'm going to rewrite what I have. I have 3a over my common denominator, 3a plus 2b, 3a minus 2b, minus, and then my next numerator, which it's just times 1, so it's just going to be 3a minus 2b, and then that's also over the common denominator. Okay, so the next step after this is to subtract the numerators. So if I just look through, I'm going to combine like terms, but the most important thing is that it's subtracting. So I like to do this, change it to adding, and then change every sign of the top numbers that were behind the subtraction. So it becomes plus a negative, basically. So now I'm going to combine like terms, the 3a, and here we have plus a negative 3a, that's going to go away. And so the only thing left on top is 2b, and then I can rewrite my common denominator. There, you do not have to FOIL the denominators together. You can just leave it separated. 3a plus 2b, 3a minus 2b. And then that can just be your final answer, just like that. So now the next type of problem is called complex fractions. These are usually pretty complicated looking, but they don't have to be hard. What we're going to do is just treat the numerator and the denominator like separate problems. So like this whole part right here, I'm going to work on first. And so to be able to subtract 4 minus 12 over x plus 2, I need to give them common denominators. So I need the 4, which is the same as 4 over 1. I need to multiply it by x plus 2 on the bottom, and also x plus 2 on the top. And then I'll still have minus 12 over x plus 2. So this becomes, when I distribute the 4, it's going to become 4x plus 8. And then over the common denominator, minus 12 over x plus 2. So then I just need to actually subtract the numerators. I can do like the previous problem, change it to plus a negative. So that means when I combine like terms, the 8 plus negative 12 is going to give me negative 4. So I'll just kind of squeeze this in. It's going to be 4x minus 4 over x plus 2. So now I'm done simplifying the top. Now I'm going to turn and work on this bottom part here. And to be able to add the 2 plus the 4 over x minus 3, I need a common denominator for those. So I'm going to take this down here a little. I need the 2 over 1 to be multiplied by x minus 3 on the top and bottom. And then I'm still going to have plus 4 over x minus 3. So then, when I distribute this 2 times here and here, I'm going to get 2x minus 6 over x minus 3 plus 4 over x minus 3. And then when I add my numerators, I can combine the negative 6 plus 4, so I'm going to get overall 2x minus 2 all over x minus 3. Okay, so now this was the top, this was what I just did on the bottom. So now my new problem, if I rewrite it, is 4x minus 4 over x plus 2 all over 2x minus 2 over x minus 3. So now the next step is to multiply by the reciprocal of this. So I'm going to say instead that I'm doing times x minus 3 over 2x minus 2, because that'll basically just cancel out that. Now, to multiply this and simplify it, I can factor anything that is factorable. So 4x minus 4 right here, I can take a 4 out. So that's going to become 4 times x minus 1. And that's just over x plus 2. That doesn't factor. And times x minus 3. And then this 2x minus 2 right here, I can take a 2 out. So taking out 2 gives me x minus 1. Now if you notice, the x minus 1 that's here and here can cancel. This 2 right here could reduce this 4 to a 2, and then I can rewrite my final answer. So I will have 2 times x minus 3 over x plus 2. And that's my final answer for that one. Now the final example I've picked out is a dividing example. So the first thing is to change this division. You're going to times by the reciprocal instead. The reciprocal of this part. So I'm going to just rewrite that problem. The whole thing is going to become x squared minus 7x plus 12 over x squared minus x minus 6 times x squared plus x minus 2 over x squared minus 16. Okay, and now we just factor everything we can. So I'm going to have from this part, I'm doing this first, that's going to be x minus 3 times x minus 4. And then under that, that's going to factor into x minus 3 times x plus 2 times, then this top part will be x plus 2 times x minus 1. And then the bottom of that one is x plus 4 times x minus 4. And then you can cancel anything that's on the top and also on the bottom, even if they're far apart like this. X minus 4, those can cancel. X plus 2, those can cancel. And right there, x minus 3, those can both cancel. And then you just rewrite whatever you're left with. So you have x minus 1 over x plus 4, and that's your final answer. Dividing and multiplying are very similar to each other. They're usually a little bit easier than the first two problems that I showed you with subtracting and complex fractions. And that's it.